Given the following thermochemical equations, calculate delta H for the formation of 1 mole of dinitrogen pentoxide. Okay, so we need to take each of these three equations and add them together. And when we add them together, we get the net reaction of the formation of N2O5. So the first thing I notice here is that in the second reaction, N2O5 is a reactant. So the first thing I'm going to do is switch that. And I'm also going to multiply it by 2 because if you notice, I have only 1 water here and I have 2 in the other reaction. And eventually I need to cancel those out. So I'm going to flip it so that I get 4HNO3. That would give me 2 N2O5 plus 2 H2O. And what does that do to the delta H? Well, first of all, it makes it positive because I flipped I reverse the reaction, okay? And so I make the negative positive, and then I also multiplied it by 2. Okay. Now, that first reaction, notice I do have the 2 waters that would be necessary to cancel with the 2 waters in the reaction that we just wrote, but they're on the wrong side of the equation, so I'm going to flip that one also. So I have 2 waters, 2H2. No need to multiply there. I just have to flip the sign. Okay. Then finally that last reaction. So notice there's 1 HNO3 here and I have 4 in the first reaction that I wrote. So I'm going to multiply that bottom equation by 4. But we'll leave it as the forward reaction. And when I do that, I get 2N2 plus, let's see, 4 times 3 divided by 2 is 6. Oops, plus 4 over 2 is 2H2. And then 4HNO3. And then the delta H, this delta H, I have to multiply by 4. So negative 174.1 times 4. So now we can do some simplification. So I can get rid of the 4HNO3 because that's redundant on both sides. I can get rid of the 2 waters because that's redundant on both sides. I can get rid of the 2 hydrogens because that's redundant on both sides. And then I have 1 oxygen on the right and 6 oxygens on the left. So if I get rid of this 1, this gives me 5. So my net reaction right now says 2N2 plus 5O2 produces 2N2O5. And if I add up all of these, 2 times 73.7 plus 571.6 plus 4 times negative 174.1, I get a delta H of 22.6 kilojoules. Okay, now we could be done there. However, this says the formation of 1 mole of dinitrogen pentoxide, and if you look here, this is the formation of 2 moles. So if I just divide this as kilojoules per 2 moles, then I get that delta H is 11.3 kilojoules per mole. Just to double check, answer 11.3 kilojoules